Live, okay. You know, I'm relearning all of this. Yeah, we should be live now. Okay, welcome everyone. Welcome, welcome, welcome. Sorry, I struggled with like starting the stream for 10 minutes or something. Time is running out. But yeah, hopefully everyone is doing well. We'll do a honestly, this will be like a 20-minute stream, even less than 20 minutes. I have my clock here. Um, But yeah, we'll try to get something done, I guess. I have some math problems I want to do, so that's all I want to do for a seminar I have today. So yeah, I guess we'll just solve one problem because that's all I have time for. So this will be like a test stream. Um, Charge my phone. But yeah, hello everyone. I kind of wanted to keep this a secret, but then again, like I would have no one watching like the first for a while. So I guess like I think it's a good thing to announce it, so I have some people to hear, right? Um, but yeah, I think everything should be fine. This is very scuffed, but I'll try to improve. Um, you know, um, every stream. But yeah, I think I have some questions here. Uh, Where are you going? Hello Lisa, hello Cookies, hello Aman, hello everyone. Thanks everyone for joining, by the way. Um, you guys are very nice. Um, but yeah. Also realized Sora is a thing now, so that's cool. Before it wasn't really a thing. Um, I can show you guys. Maybe I should just get into the math, but I want to show this because I think it's cool. So I think OpenAI released this new like AI tool. So this is how I created like the thumbnail as well. Yeah, it's pretty cool. It's like really accurate. Like I asked for several variable problems, and this is literally a several variable. Like, yeah, it's a several variable function, right? And it's derivative, or partial derivative, or wait, with input x plus 1, x plus y. I mean, I don't know if I agree with this, um, but it's actually kind of accurate. I remember when it wasn't accurate, like a year ago or something. But yeah, hopefully the audio is pretty well, or like, you know, hopefully everyone can hear me well, and yeah. The camera setup is also a bit different from the usual one. Several title, is it wrong? Oh, severable. Oh my gosh, that's something else. Several. I think I mashed together several and variables. Severable. That's good. Wait, let me just check the questions I have for today. Okay, we have 15 minutes. Let's go. Let me look at the canvas. By the way, do you guys use Canvas as well, like for a for your courses? I'm not sure if it's like a global thing. No, that's the wrong one. There you go. I think I've already done a couple of the questions on my notebook here, as you can see. Well, maybe I'll try to do them again. Yeah, I think this one. I think there was one that I enjoyed doing. I think yeah, this one's point 15. All right, so these are surface integral problems, or no? yeah, I guess surface integrals, right? Also Blackboard. Wait. Oh, Blackboard Learn. They're similar. I think Canvas was better UI. Ah, okay, interesting. Nice. Yeah, I guess the only thing I've used is Canvas, and then there's a Google like software, or like a whatever you call it, called Canvas, or no, called Classroom. That's basically what we use during like high school and stuff. But yeah, let's turn this off. Okay, so I think yeah, the first problem is um should I write this down? Right, so we have the integral. I hope this works as well, yeah. Yeah, so this will be a rough stream, by the way, guys, and I know this. It is rough, but we'll do our best, okay? Right. Right, so our sigma is a surface in R3, right? It's part of the surface. So sigma, part of surface y z x square, that lies in the first octant of 3 space, and inside is the first octant, and also inside paraboloid. Z like this. Seems like I'm attending my maths class. Yeah, I don't know. Maybe I'll change the format later, but yeah, we'll see how. I'll just. I think it's good to just try stuff out, right? Hopefully you can see everything here. My webcam is kind of messing it up, right? But I think if we do the answer here. Do. Right. So let me just recall some stuff. Maybe I can look at my notes, see how you did it, because I'm yeah. So if I recall, we first want to parameterize. Yeah, right. Right. All right. So we know that we can write our z function as a function of our x and y, and then we know that we can write yeah, right. So we can write this. Maybe we'll call it z as well, right? Maths nerds will be blessed now. Yes. Yeah. Why call it f? We'll call it z, right? That makes more sense. Offer emotional support because I didn't understand half of the question. I mean, it's yeah. But I would say, like, if I would try to explain it, because I'm not sure if like this is also something new for me, right? So we're trying to find if we have a surface here in R3, right? Some kind of surface, and this surface is given by and this surface is called sigma. and we have two functions which the intersection of these guys give a surface. They're just trying to make it confusing, right? Mu, haven't started my 11th grade maths yet. I think it's a sign for me to start. Yeah. But basically, yeah, we have our surface here in R3, and we want to I guess there is a intuitive picture here where we can see this as the mass, um, and this function here as our density, and we're basically finding the mass of this surface. I think that's the intuitive picture that my lecturer gave me. But oh, you can't even see it. But I guess if this is our density function, we're trying to find the mass of this surface. But I guess it's kind of deep to give like a overall picture right now. But yeah, that's a short and clear explanation. I hope that's the case. I'm not sure if I gave a good explanation, to be fair. But anyways, I think there is a theorem saying that if we can describe one of the like the like one of our coordinates as a function of the other ones, we can write it as this, I think. Right. Shoreline, I want to get at least one this start of the question. So I'll look at my notes because I think I did most of this before. I think I did xy. Oh, it's actually xz. That makes sense. Oh, that's interesting. Yeah, it's I'm not sure if I completely understand this, to be fair. Right. Let me just think for a moment. Yeah, so I think you can see okay. Right, so I think you can right. So I think you do it like this, actually. I think I got it. Or I guess I'm remembering how I did it. Your questions will join later, right? Yes, thanks, Lisa. I'm not sure if this is, or I'm certainly sure that this is not really something that everyone is interested in, but it's certainly something that I want to do. So yeah. Let's see here. It's a very niche topic that I definitely understand. But it's let's see here. So I think our first function here is, let's see here, is some kind of, what do you call this? A hyperboloid? Some kind of, something like this. And then our second function is another kind of hyperboloid. I'm not sure if we need to draw it. I think it's something like this. Maybe I'm completely wrong. Maybe I'm not actually. And then we can view our projection along the y-x axis. This will be useful when calculating the second derivative, or the like the surface, or the whatchamacallit, the double integral, right? And this projection will be an ellipse. So if we substitute this, we can rewrite this as right, as y squared plus 4x squared is equal to 1. I think that's how I did it. Yes. Should probably center myself, right? And this we can see as an ellipse. Yeah, I think it's kind of obvious. I think I did something wrong in my notes actually. Yeah, that makes no sense. Yeah. Yeah, and this maps to some kind of ellipse like this, I think. Noise. Let's see here. How much time do I have? I think I have like 1-2 minutes left. But let's try to get at least somewhere with this. Right. Okay, I understand what I did here. So we want to get it on the standard form of the ellipse, right? So I guess you would do it like this. Right, and this would actually be the other way around. Yeah, like a half here and then 1 here. I think something like this. You're doing area under curve, basically. It's or I wouldn't say so actually. It's not really an area under a curve. I'm not sure. It's more like a mass of a curve, right? I guess if you would physically interpret it. Right. And how you would interpret like a single variable, like definite integral, would be more like the area under a curve. Yeah, I think that's correct. All right, but we have our ellipse, and this is where we need to integrate over. So that's noise. Right. So now I think we can just yeah. So now we can simplify our surface integral into being I guess I use some result. I use this result up here. I don't know if you can see it here. I guess I can use a highlighter. Oh gosh, that's wrong. Yeah, I use this result. If you can write it as if one of the coordinates can be written as a function of the others, that we can write this as if we take the partial derivative with respect to x. What do we get? We get 2. That's 2, so that's 4x plus our partial with respect to y, so that's 2y, I think. I see. Let me just think. Is that result just known? I mean, you can derive it. I think you can derive this, or I know you can derive it fairly easily. Yeah, I think it's something like the general surface integral. If you have some kind of surface, it's actually good if I recall this because yeah, it's actually very good. If you have some kind of parameterization of a curve, I guess we'll call this RST, and yeah, right, and we can write this as, yes, this is important. So we have two variables that we can make a surface out of. I'm not sure if this is a familiar concept. This is too much for my brain. Yeah, it's fairly niched. I mean, if you're not into this, it's obviously not something that is, comes easily. Yeah, but yeah, and then the general form which can be proven is that you can write that that every surface integral can be written as this, and also we have the like this like the field vector. I think I walked in at a in a scary time. Yeah. I mean, I'm not sure. Okay, this is actually getting very late. This is I would say it's fun talking about this. I'm not sure if yeah, but I think I just need to end it here. And yeah, I mean, it was a good time. I have like 5 minutes to get ready, but yeah. I'll try to do these streams every morning. Hopefully they're longer, and yeah. I guess I'll just end it here. Thanks everyone for joining. And yeah, well, it looks fun and interesting. Yeah, it's very interesting for me at least. I find it, yeah, truly interesting. Anyways, yeah, I'll see you guys. I guess if you're gonna join the Study With Me stream, that will be